Okay, let's talk about the type of base metal. We're on page 319, chapter 12, left-hand column underneath type of base metal. The nature of the material to be welded is of prime importance. Satisfactory welds cannot be made if the weld metal deposited does not have the same physical and chemical qualities as the material being welded. We know that, we've been talking about. Underneath the material, let's continue reading. If the material specifications are not known, simple tests such as spark test, torch test, chip test, magnetic test, color test, fracture test, and sound test may be performed. You can look these up on your own. You know, Google spark test, welding spark test, magnetic test, so forth. You also deal with some of this in the Metals Prep course 202. I'm going to continue reading so we can keep moving forward. The information in tables 12-9 through 12-12 will help you recognize the various metals according to their characteristics. Such information can, however, identify only broad categories of material. The welder may be able to tell, for example, the material steel rather than cast iron, but there are so many types of alloy and stainless steels that it's necessary to know the correct analysis of the steel as designated by a manufacturer. For example, if the steel is high in sulfur or carbon, or if it contains certain alloys, the 7015, 1618, or 7028 electrode should be chosen. The reason, these electrodes reduce the tendency toward underbead cracking that is characteristic of such steels. They produce welds of high tensile strength and ductility. Without stress relieving, they reduce or eliminate the need for preheat. So just in that section alone, is what I wanted to make it a point to say. You're going to get out there and you're going to say, how do I know? Right there, if there's certain alloying elements within it, it chose 70, 15, 16, or 18 a low hydrogen electrode, correct? So we're pretty safe most of the time, unless it's some specialty material. The majority of what we'll be dealing or welding on will be a mild steel. If not, your parts, whoever's purchasing the parts or materials, your foreman, will definitely know, because it's a lot higher or a lot more expensive material to buy. So he's going to make sure to tell you, look, this is, T1 type. We need to preheat and everything else, because if it cracks out, then it's a bad product. So we're pretty safe on most cases of welding mild steel. 7018, a good selection, all-around selection, pretty safe welding with it. Okay? All right. So here's just a quick chart of temperature data. Here we talked about the melting point. So pure irons right here under 2800, it's 2780. Stainless, 12% chromium. Chromium is up here around 2950, looks like 2930. And this all depends on a little bit of percentages within them as well. Pure iron at Stealth, 2800. Mild steels, 2730. Okay. All right. We talked about this yesterday. I'm not going to touch too much. AC, DC, influences selection of the electrode, blah, blah, blah. You can kind of look through the tables and go forward with that. Okay? Back up here. I do want to show you one. It's not even on here. It's not on this slide. But if you go to page 12, or to table 12-9 in your book, so it's page 320, chapter 12, look down at the bottom. Aluminum itself is about 1250 degrees. That's a very low melting point. So starting out here, you can look at brass, bronze, zinc, lead, tin, aluminum. Boy, a whole bunch of materials in there that we're going to deal with. Okay? All right, just to get you thinking in that direction. Page 321, chapter 12, welding position. Okay, real quick, let me hit just the beginning sentence of that first paragraph. Position of welding is a very important consideration in the choice of an electrode. Certain types of electrodes can be used only in the flat position. Others perform equally well in all positions. The type of position also has an influence on costs. Welding is most economical in the flat position, then horizontal, then vertical. The overhead position is the least economical. As you develop skill in welding, you will understand the limitations that welding in the vertical and overhead positions places on the choice of an electrode. So we talked a little bit earlier about welding position and electrodes. You can read the next paragraph, and there'll be a bolded item out of that. Again, the most economical would be flat. Skip over to the right-hand column, first paragraph down, it starts out, and this is a bulleted item. For production work, the largest electrode size that can be handled should be used. Doesn't mean everything's got to be 1/4 inch. It's all in the variables. The largest one that will produce a good solid weld. Okay? All right. Type of structure. Where we at? Conditions of use. Page 323. Left-hand column. Start reading from the book. The service requirements are of utmost importance. The type of structure and the stress that will encounter in use must be considered. Tensile strength, ductility, and fatigue resistance are important weld characteristics that help to determine choice of the electrode. Note the variation in weld metal properties among the electrodes compared in table 12-3, page 312. The next paragraph below that is actually one of the most important ones, in my opinion. The engineering specification. When in doubt, make sure you always go to the engineering specs, if you have them. Most shops, your foreman will be able to tell you, okay? But if you're welding to an engineered print or a spec, make sure you follow it, because it's going to be checked for code quality or QA check at the end of it, okay? So, back up to production efficiency. I want to read a little bit from the book on production efficiency. Okay? Page 324, top left-hand column, first full paragraph down, it starts out, the principal factor in the cost of a welding job is the speed in which the welding can be done. Electrode cost is small by comparison. 70, 24, 28, and 60, 27 electrodes permit the highest rate of deposition. 60, 20, 13, 11, and 10 follow in the order. Type of steel, not speed, should govern the choice of the 7015 or 7018. 7028 is similar to the 7018 but has a much thicker coating that contains a higher percentage of iron powder. Thus, its deposition rate is much higher. However, we notice now 7028, it's limited to flat and horizontal only. 7018 can be in any position. Okay? So, just a quick idea there. Has a much thicker coating. The speed, and this is why if it's going to be done inside of a welding shop, you're more than likely not going to be using shielded metal arc welding electrodes. You're going to be using gas metal arc welding or a flux core arc welding electrode. Speed, time, money, all of it plays into the efficiency and the principal factor. Okay, let's go down to, you can read through job conditions on your own. Hitting some highlights. Again, this is all good information, but I don't want to have to read the entire book. You can come back through the PowerPoints, pick up what you need to. I'm going to hit a few highlights for you. All right. I'm going to do 6010 electrode. Page 324. Specific electrode classifications. Main thing I want you to think about here, read through this, but it is an all position fast freeze DC electrode positive. Okay, it can be used in all positions, and in this case both progressions, uphill and downhill as well. Skip over to the next page. It's 325, left hand column top. 6010 electrode is commonly classified as the cellulose type. Not seeing it here. Okay, page 325, back to where we were, left-hand column, top, first full paragraph down. 6010 electrode is commonly classified as the cellulose type. The electrode coating contains considerable quantities of cellulose, either in a treated form or as a wood flour or other natural forms. Okay, next paragraph down, this type of cellulose electrode needs a certain amount of moisture present in its coating and should not be stored in a dry rot oven. Very important as well. You dry it out, it's going to crumble and fall all over. Okay? So, it needs to have moisture within it. Read through the rest of that chapter on your own. 6011, the next one, I want you to read through that paragraph and that rod designation, as well as E6013. You can read through these bulleted points and PowerPoints here. Okay, let's go to low hydrogen electrodes. Low hydrogen electrodes are a result of research during World War II. The object of this research was to find an electrode for welding armor plate that would require the use of less strategic alloys. Move to the next page, 326, top left-hand column. The name stems from the fact the coatings are free of minerals that contain hydrogen. Lack of hydrogen is an important characteristic because hydrogen causes underbead cracking. I would circle and know that very well. Hydrogen causes underbead cracking in high carbon and alloy steels. By eliminating hydrogen, underbead cracking is prevented and difficult steels can be welded with little or no preheat. These electrodes also produce porosity-free welds in high sulfur steels and eliminate hot shortness in phosphorus-bearing steels. The addition of iron powder in the coating increases the deposition rate. Shielded metal arc welding electrodes have classifications ending in 5, 6, or 8. There we are again. Okay? So, just kind of reconfirming what we've already talked about. 5, 6, or 8, low hydrogen. Okay. Now, let us drop down one paragraph. So the low hydrogen electrode has a core of mild steel or low alloy steel. The mineral covering consists of alkaline earth carbonates, fluoride, silicate, binders, and ferroalloys. This covering produces the desired weld metal analysis and mechanical properties. 7018 and 228 have iron powder in their covering. During welding, the covering forms a carbon dioxide and shield around the arc. On the job, these electrodes must not be exposed to humid air because of their tendency to absorb a considerable amount of moisture. Again, same thing. Keep them dry, keep them clean. Next paragraph, keep continuing. Continue reading. A wide range of weld properties is possible by adding a number of alloying elements to the covering. Such additions may include carbon, manganese, chromium, nickel, molybdenum, and vanadium. You're going to see this in quite possibly other designations. So, for example, the shop we have it. Just give you a brief summary, just one real quick to get the point out. I'm going to go with 8018 C1. Okay, so 80,000 tensile, all position, low hydrogen. What does this mean? This means that's the additional alloying element within the material, okay? So in this case, it has a certain percentage of up to C1, C2, so forth, can be up to 2%, 0.2% nickel. Why is that important? Well, anybody that's tried to weld AR400 plate, it's a hard plate. It's designed to rub against the ground and have some wear resistance for it, basically in road graders and equipment. Designed to resist abrasion more than impact. But it's very difficult to weld. If you just tried to weld this with 7018 with no preheat or anything, you would start welding, you tack it together, you start welding, and about a few inches into it, all of a sudden you'd hear bing, and that weld just cracked and split right down the center. Very common. So if you're welding an AR400 plate or a hard-facing plate or a wear-out plate, then you might want to be looking at still doing preheat, but also welding it with like 8018 C1, which is like a 0.2% nickel or something to that effect, okay? So that's where some of these portions of the welding rod and so forth will tie into the selection you're going to use in the future.